Hey everyone, let's attempt some practice problems from the book. Just to let you know, I copied these from the ebook. Both of them have solutions. We're going to do an in-depth problem solving of them though, okay? Now, we are given two curves rotated about the axis y equals 1. Now, when you see that, you draw your picture, which of course we should always be doing. Well, we ought to make our y-axis a little bit higher than normal, right? Because again, y equals 1 is going to be our axis of rotation. Now, these curves should be pretty familiar, right? Y equals x squared. X equals y squared might look a little weird, but remember that's y equals the square root of x, and y equals negative the square root of x, right? Make sure to get that bottom half too. Turns out, actually, we don't really need it because these curves intersect only in the first quadrant, but it's good to draw that stuff regardless, right? Right. So anyway, that's our region, right? Something we've seen before. Now let's rotate it about the line y equals 1. So do your best at reflecting this stuff, right? And you'll see that you have a shape kind of like a, I don't know, it's like a tulip or something. Okay, something like that. And if we zoom in a little bit and maybe we fill in our cross section, we've got that, right? Just to illustrate our outer and inner curves, right? This is y equals the square root of x. This is y equals x squared. Okay. All right, and let's go about solving the problem, right? Find the bounds, set up the integral, integrate. Find the bounds. Right? Let's, right? X squared equals the square root of x. So, right, you want to subtract them, right? So you get x squared minus the square root of x equals 0. You can then factor out square root of x. And if you know a little bit about factoring and know some combinatorics or whatever, you can actually factor this a bit further. You don't need to. This is x to the 1/2. I'll write it as root x. You can actually factor it this way. If you want to, you don't need to know this. You can skip ahead. But anyway, the point is, these are your factors right here. So you can see that x equals 0 and 1. Again, if you had a good drawing or if you've just seen this stuff before, then you probably could have intuited that. But I do need to see some kind of equality like x squared equals root x to get full credit on that, okay? So, moving forward, we're going to get the integral from 0 to 1 of, right, we know we're integrating with respect to x because we're rotating our region about a horizontal axis. Well, then it looks like we're getting the area of that first curve. Actually, let's use red because it looks like red is the outer curve. Well, what is the radius of that region right there? Looks to me like it's 1 minus that distance, which is x squared. Okay. Minus pi times, and you might imagine this will be a similar deal, right? What's this distance? The radius of that small, thin blue circle, right? What is that? Well, it looks to me like it's 1 minus this distance, which is the square root of x. Okay. And then from here, it's just a bunch of simplification. Do the integration, make it happen. I recommend pulling the pi outside the integral. Right, FOIL this out, you get 1 minus 2x squared plus x to the 4th. Minus, be careful distributing that negative sign, please. Minus 1 plus 2 root x minus x dx, right? Notice your 1 and your minus 1 cancel out. Everything else should be pretty good, I think. And you're getting pi times negative 2/3 x cubed plus 1/5 x to the 5th plus 2/3, actually I think it's 4/3 x to the 3/2 minus 1/2 x squared. And we're plugging in 0 and 1. Note that when you plug in 0, you will get 0 for everything, so just keep that in mind, but in general, always be careful about that. This will be pi times negative 2/3 plus 1/5 plus 4/3 minus 1/2. We can do a little bit better than that, I think. Pi times 2/3 plus 1/5 minus 1/2. We can do a little bit better than that, I think, right? So we get pi times, I guess that's 20 plus 6 minus 15 all over 30. And that's 11 pi over 30. And sure enough, we check our work, or at least our answer. We get the right answer, okay? So that's how you do that guy. Let's move on to number 15. Y equals x cubed, y equals 0, x equals 1, all relatively basic, about x equals 2. Okay, well, x equals 2 is in the first quadrant, so maybe when we draw our picture, which of course we should always do, maybe we'll make that x-axis a little bit bigger, because we know that, x equals 2 is going to be involved. Now let's do these one at a time. Y equals x cubed, y equals 0, okay. Oh, wait, no, y equals 0, okay. X equals 1. Okay. So if we rotate this about the line, x equals 2. Then we're going to get, all right, you don't really need to know that this is 3, but it certainly helps. Something like this, right? Not perfect symmetry, but pretend it is, okay? Now this we're going to have a little bit of an interesting situation that we might not have seen before, right? Again, this is y equals x cubed. This is x equals 1. So maybe I won't write that inside here. I'll just write it up here. X equals 1 in blue ink, so you know what I'm talking about. Now, just to note, we're rotating it about x equals 2, so actually we're going to be integrating with respect to y, right? So maybe I should write this as x equals the cube root of y. All right. And the other curve here is, of course, y equals 0. Now, when we rotate, or we revolve our region, what can we get? All right, so we get this. Let's try to color it in. Think about what shape this is. It's like a hollowed out tree trunk or something. Like, I don't know, if you cut off the bottom of a clarinet, maybe. Maybe not quite. That's a little curvier. Right? It's like if you just took a tree trunk and just drilled a hole right through it. Right? That's what you get. Okay. All right. So let's take a look at what happens here. Same thing as always, right? To find the volume, we have to set up the integral, find the bounds. Okay? Find the bounds. So we set the curves equal to each other. Now remember, we're integrating with respect to y because we're rotating about x equals 2. So we want to make sure we set y values equal to each other. Remember, this is the y bound that we're interested in. So it looks like we want to let the cube root of y equal 1. Right? Because those are the curves we're working with. So we have that the cube root of y minus 1 equals 0. And so if you know, you can cube both sides, whatever, but you get that y equals 1. Right, again, if you want to do some fancy schmancy factorization, then you can. Not really worth doing it. Okay? So y equals 1. That's it. That's the only solution, which kind of makes sense. Again, if you look at our picture, looks like it should probably be 1. But when we set up the volume equation, something kind of interesting happens, right? We've been given y equals 0. That's where that came from. Just highlight that to show you. Y equals 0 comes from here. 0 to 1. And 1 comes from this, right? Okay. We have to do outer minus inner, right? So again, it's going to be pi r squared, as it always is. But what is it? Well, r in this case looks like it would have been 2 if we had been able to travel all the way back to x equals 0, but we got stopped by that curve. So I guess it's 2 minus the cube root of y. And we'll square that. Minus, and then here's where it gets even a little more unusual, but I think it's in a good way. What is the length of this curve? It's 2 minus 1. Otherwise known as 1. Do you see that? No matter where your cross section is, this inner circle always has radius 1. It's kind of nice, right? So, with that in mind, right, the outer radius is always changing, right? Outer radius gets a lot bigger. Okay, but that inner radius is still always 1. Okay, so just keep that in mind. All right, and now again, at this point, it's just a whole bunch of simplification, integration, you know the deal, right? Pull that pi outside, FOIL, etc. 4 minus, this is going to be 4 y to the 1/3. I highly recommend writing it as a power so we can do the reverse power rule more easily, right? I have to be a little careful here. This is actually just going to be minus 1, right? Because 2 minus 1 is 1. Factored out that pi. So that's actually kind of nice. Right? Of course, 4 minus 1 is 3. You can rewrite it that way. Right? I'm just going to skip the step and integrate. So we're going to get 3y. Again, 4 minus 1 is 3. Integrated becomes 3y. Minus, I think it's going to be 3y to the 4/3. Yeah, I think that works out. Plus, and I think this is going to be 3/5 y to the 5/3. 0 to 1 up, and see, I almost forgot about that pi, but I didn't. Right, let's keep it going. Pi times, again, we plug in 0, we get nothing. That's not always the case, but it is here. Oh, well, we're going to get 3 minus 3 plus 3/5. I think that's pretty easy. Right, and let's one more time carefully look over our work. Do we think we have the right answer? Let's take a gander. Looks true indeed. That's all we've got for this time. Thanks for watching.